training finished. You see after 5 epochs, approximately each epoch took like 1 minute, with it was about 33 milliseconds per step. This is the loss, training accuracy, validation loss, validation accuracy. So it seems that our model was learning, accuracy is increasing, validation loss is decreasing. You have to check also the validation loss and validation accuracy to make sure that your model is not overfitting. The next thing we will do is that we will get the accuracy key. As it differs whether you are using TensorFlow 2 or a previous version, so this is just a very simple way to find the correct key for accuracy. Now we need to get to know what was happening during our training. So this is the way to get the accuracy history, what happened during the 5 epochs, accuracy of the training, validation accuracy, loss and the validation loss, and so that we will be able to draw the curves. So let's start with plotting the curves for the training loss and validation loss. Here it is. So the blue one is the training loss, the red one, the red one is the training, and the blue one is the validation loss. Okay, now for the accuracy, here's the accuracy. Again, the train is the red, the accuracy, the validation accuracy is the blue one, and as you can see from the epoch 0 to 4, which is actually 5 epochs, losses were decreasing and accuracy was increasing. Now let's test our model by printing the confusion classification report and the confusion matrix. So we are using here the function model.predict. It's a very convenient method to run the prediction and see the actual output of our model. Now our model is trained, and we use the prediction.argmax to get the highest probability of the last softmax layer. So if you run this, it's now evaluating network. It might take some time. Okay, and this is the output. So this will give you all the information. These are the labels you have from 0 to 9, and this is the precision, recall, F1 score, and the support. This is worth to check to make sure that you have a balanced data set. And this is the overall accuracy macro, average and weighted average. And then we have the our confusion matrix. So confusion matrix is also a very convenient way. What do you really care is that the diagonal values are the highest values, but you would know now that some of the zeros were actually classified as ones. Some of the ones were classified as 0, 1, 2, 3s, and so on. But it seems very good because the diagonal has the highest values. And just to explore more, we will get the indices of correct and wrong classification. This will give you information about exactly what is the so it will print the misclassified. This will print the misclassified indexes. What are the inputs that were not correctly classified, and then we can show some samples of the correct classification. So this was 2, and prediction was 2, and the ground truth is 2. So this one is correct. It's actually a very difficult 2. What we are doing here is that we know the valid classification. See, we know which one were classified correctly. This is the one we are feeding randomly. So each time you run, I guess you'll get like a different sample, but always the sample will be correct because we know from the valid classification indexes. Now let's see one of the wrong classified ones. So I guess this was 7, but the ground truth was 2. If you run again, I guess you'll get different. This testing ground prediction is 5, but the ground truth is 9. And this is how we can visualize the output and see which samples you got correctly and which samples you actually didn't get correctly. Thank you.